Hi, everyone. My name is Jeremy Ventura, Director of Security Strategy and Field CISO here at ThreatX. And in today's session, I'm going to teach you how to build an API security program. For today's agenda, this session is actually going to teach you the best practice on how to start, evolve, and mature your API security program over time. We're going to cover topics such as red teaming or offensive security, blue teaming, which is defensive security, and how does that incorporate to what we call purple teaming, which is really the collaboration of both those teams. We're also going to explore the evolution of APIs, their increased utilization in organizations. Also, how are they becoming targeted from attackers and attackers? Where are they vulnerable within your organizations? And how are attackers able to exploit those vulnerabilities? Lastly, we're also going to cover how to actually gain a great ROI or return on investment on your API security program once it's already been built, and how you can actually demonstrate those key metrics for effectiveness. So let's get into it. And why are we even talking about API security in general? Well, as we know, almost every modern application uses an API or is actually an API itself. Digital transformation and initiatives have allowed organizations to develop faster and faster, which allows them to connect to other internal and external tools. And with this actually comes a challenge. APIs are becoming more targeted and more vulnerable than ever. And really the issue, in my opinion, starts with visibility first and foremost. Do I know what's actually in my environment, who owns it, and what's the intention of that API? As we can see here from a different chart, APIs have exploded. Just in January 2021, we've seen developers using over 90% of APIs, and that increased usage continues to grow into 2023 and beyond. So with increased usage comes increased risk. But where do I start and how do I build this program? As I mentioned before, a lot of this actually starts with visibility, understanding what's on my network. Do I have an internal API? Do I have an external API? What is the intended function of that? How is that API written? Is it in JSON? Is it XML? Is it a GraphQL API? Once I discover that, it's then about documenting those APIs and cataloging them. So we also can call that schema management, understanding the intended usage of this API. How was it developed? What was the code? Who has access to this? From there, we go into ownership and usage. Is it certain developers within my organization that have access to this API or API keys? What is the intended usage of this API? Is it designed to make external calls or 5,000 calls every second? From there, once you've actually started to gain a good visibility and understanding of how the APIs and the intended use of that, we can also start to look at what we call rogue and zombie APIs, or what we've also known in the industry as shadow APIs. Those are sometimes the APIs that we don't know exist within our network or are making public calls, or maybe a developer created the API months ago for an intended usage or a specific use case, but it was never decommissioned, for example. These rogue and zombie APIs are also in a very high extreme point of how attackers are able to attack your organization. So once we start to understand the inventory, the discoverability of your APIs, we then want to focus on, well, how do we go and actually protect these APIs? Now, I'm going to cover here red teaming and blue teaming and how this collaborates into purple teaming. We could have put 100 different recommendations on actually how to secure your APIs, but I just listed top 3 from each side based upon best practices. A lot of APIs are attacked by attackers via weak authentication or authorization. So we want to make sure first and foremost from a red teaming standpoint that we're ensuring that authentication authorization mechanisms are working as intended and that only authorized users only have access to the API resources. So we want to make sure that we're testing for weaknesses in these mechanisms such as weak passwords, insufficient validation of access tokens, and then also from an authorization standpoint, who is actually authorized to access this API. From there, we move to encryption. So make sure you're testing your API's encryption mechanisms to ensure that they're working as intended and that sensitive data transmitted over this API is actually being protected. This can include tests for SSL, TLS, encryption key strength, and other encryption-related issues. Last and foremost, we want to look at rate limiting and throttling. So test these APIs against these mechanisms to ensure that they're able to prevent abuse and protect against, for example, denial of service attacks. So can my APIs handle high volumes of traffic? Is it normal behavior for an API to be called on so often? And can it gracefully degrade in the event of a DDoS attack? From there, we move to blue teaming or the defensive side of security. And I like to always say this is really a defense in depth or defense in layer approach. And so API gateways is one approach to use, which acts as really a mediator between the API and external clients. This gateway can enforce authentication, authorization policies, validation of requests and responses, and provide other security features such as rate limiting and throttling, as we mentioned from the red teaming side. From here, though, once I've got an API gateway, we want to make sure we have accurate and efficient logging of what your APIs are doing. So a critical component of securing APIs is actually the monitoring of this. This involves tracking API activity over time, identifying potential security threats, and responding to incidents as they arise. Last and foremost, we believe in API and application protection. You can't protect what you don't see, but you also need what we call real-time blocking. So partnering with security vendors like ThreatX that include platforms that include discovery, the cataloging, the real-time actual protection and real-time blogging, and making sure that your APIs are protected in production. Once we put this all together, you got red, you got blue, and those two colors together make purple. And purple teaming is really a collaboration of both of these processes and teams together. And I always like to say purple teaming starts with the tale-old story of cybersecurity of people, process, technology. And I specifically put people first because no matter what technology you have in place, people are still the weakest links within organizations. And so I want to emphasize the importance of training and awareness, making sure we have security awareness training, not for all employees, but also making sure we are dedicating that security awareness training to even development, right? Our software engineers, our software developers, making sure security reaches across the aisle and is having a transformative conversation to make sure that that awareness is happening. So we're actually protecting our applications and developers all the way through the SDLC or software development life cycle, all the way to production. From there, we also want to talk about process. So making sure, as I mentioned before, we're actually stress testing our APIs, making sure we do a tabletop exercise against what a DDoS attack would look like or what a botnet attack would look like against our applications. What would happen if we had downtime? From there, you want to make sure you have flexible policies and procedures, that they're flexible. And that's the key point here. Policies and procedures should be changing over time as new threat actors are advancing their techniques against your organization. Last but not least, we talk about technology. As I mentioned, defense in depth, making sure we have gateways, making sure we have API protection platforms and solutions in place to protect against real-time threats. From there, it's always good to make sure your organization is at least doing annually, if not way more often and way more fluid pen testing and vulnerability assessments against your applications and APIs. Now, once I start to build the red teaming, blue teaming, purple teaming, how do I actually mature my program? How do I prove the effectiveness? Once again, we could have put over 100 different KPIs or key performance indicators and metrics on how to actually demonstrate the effectiveness of your program. But here I just picked top 5, such as how many APIs do I have? Are they internal? Are they external? What are they connecting to? What percent of my APIs are actually being targeted or have threats against them? What percent have actually been blocked, whether it is at my web application firewall or with another solution in place? From there, what has been my average or quarterly uptime or availability of my applications? Am I meeting my SLAs for my customers? And then last but not least, looking at your top 3 attack vectors. So is it SQL injection? Is it cross-site scripting? Is it credential stuffing that's hitting my applications and APIs? And how are we trending? Are we getting better over time? Are we protecting our applications? Or are we degrading over time? So once you've got all these metrics in place, you've now started to build a conclusive API security program here. That is all the time we have for today. Nice, short and sweet, but we talked about how to start, which is really about visibility, discovery, cataloging, red teaming and blue teaming, and then also what that means for purple teaming and all the best practices there. And then last but not least, the metrics to prove effectiveness. Thank you everyone for joining this session, and look out for ThreatX.com to learn more about different sessions that we're providing and how ThreatX can help you protect your APIs and applications. Thank you very much.